All right, we are back. This is lecture 9, our next lecture on iOS. So today, we'll see how much we actually remember from last week, which was our first head dive into this sort of stuff. We'll talk about the MVC architecture that's supported by iOS, and then some more fun and practical topics, namely gestures, how you can actually respond to pinches and swipes and twists and turns and such, as well as storage mechanisms, how you can actually store data persistently with an eye toward the next project, which is, again, Evil Hangman. So a bit of review. We made this application last week, recall, which allowed me to type in my name up top, click the Go button, or hit Enter, and then what happened? Sorry? Exactly. A little alert popped up. It said my name, and then I dismissed the alert, and the name field goes blank again, and the game begins anew. So verbally, if we could, how did we go about writing this application? Can we tell this story from start to finish, being as technically precise as possible in terms of functions and methods and class names? And I'll try to guide us toward a reasonably accurate story. So I created a new Xcode project. And what template, just to get things started, did we start with? Anyone remember? So single view. So this is one of the simplest ones. It's a notch above the empty application, which gives you no view controller and no views by default, which you would then have to construct manually. So single view is a nice place to get started. Of course, for Evil Hangman, as you may have seen in the spec already, it asks you to start with a utility application so that you get 2 view controllers out of the box. But more on that later today. All right, so I've created the template. And in terms of the code that I'm given by default, I'm given a few classes and files right out of the box. What were those, if you recall? So an app delegate, so there was a class called app delegate. What else? View controller, and that came in the form of 3 files. One was a .h, a .m, and a .nib. So .xib, which was the optional mechanism for creating the user interface via the drag and drop interface builder tool. What other files did we get that are germane? Main. You got main.m, inside of which is the main function. And then a few other files. There's a .pch file, precompiled header, but generally we won't care too much about that. There were a couple of plist files and .strings files, which have to do with localization and with various default settings. We'll come across those probably next week in a little more detail, but for the most part, they weren't that interesting. All right, so now let's start telling the story. So you go ahead and launch an app on the iPhone. What's the first function to get called? Main. It's really just a C program at the end of the day. So main gets called. Inside of main was another function call called UI application main that we didn't really look at in any detail, but ultimately that function somehow hands off control of the application to whom? Okay, yeah, careful. One step in between, in the middle there. So to the so-called app delegate, which we'll look at in more detail in a moment, but it's just a class that we got out of the box. So we have main, we have UI application main, we have the app delegates, and what did he then do? Rendered the view a little bit. He's got to do a little something before that. There was a application did finish launching with options method inside of the app delegate. What did he do, among other things?
Created a new view controller.
Okay, good. So it instantiated a new view controller and initialized it with that nib file by way of the nib's name. And then it remembered that view controller as with a pointer, a property specifically. And then finally, what happened? It made itself the key window and visible, at which point who took over the rest of the story? The view controller. Okay, so the whole lot of layering is really the takeaway there. And it's totally fine if a little of that was rusty or just completely gone from one's recollection, because we'll get our hands dirty with this in much more detail. But understanding the flow there and at which point control is really handed off to you, I think is a helpful way of really diving in so that you don't just kind of close your eyes blindly to everything you're handed, but you actually do genuinely understand what you've been given outside of the box. So let's take a quick look in more technical detail at such a project. So I'm going to go ahead and launch Xcode. I'm going to go ahead and in the templates menu, make sure that under the left-hand side menu, I choose iOS, I choose application, and then I'll go ahead and do single view application. I'm prompted with a few names, so we can just call this nib 3, just to continue last week's story, but we won't actually write much code here. Company identifier just has to be unique. We can leave class prefix blank. I'll target the iPhone so it fits nicely on the screen. We'll leave storyboards blank, but in section last week, recall that there was a dive into storyboards, and you're welcome to use those in general, but for the first project, we specify using nibs. Automatic reference counting. We'll talk about this in more detail probably next week as to the magic that that's doing for us, and then unit tests 2 we'll come back to in a week or two's time. time. Let me go ahead and click Next. I'll go ahead and create a local Git repository, store this thing on my desktop, and there we are. Everything that we just walked ourselves through verbally. All right, any questions on the overall flow of an application from start to point of handoff to the view controller, or any questions about Xcode, anything that would help clarify where we're about to go?
You may be planning already to get to this, but what happens when another app on the phone starts something analogous to the lifecycle of Android?
A really good question. So if the current application is interrupted, a phone call comes in, a notification drops down, you hit the home button, you power it off, you lose power. Well, actually, lose power is the corner case there. Generally bad. But let's take a quick look then inside the app delegate. So the app delegate is where a lot of sort of very high-level functionality, actually, where very fairly wide-reaching application behavior is defined. And by that, I mean how the application itself, no matter what view controller it's inside, responds to things like interruptions, to backgrounding, to the sort of alerts that might happen during everyday phone use. So again, this is just template code, and the only method we spent any time on really last time was this one here. Application did finish launching with options, and if you were just taking on faith the verbal story we told, this here was the line last week that actually did allocate the view controller, initialized it with the nib. In the next line, we remember a pointer there too. And then finally, this is where we just left off that story. But if we scroll down further in the file, notice that there are a whole bunch of stubs for methods called application will resign active, application did enter background, application will enter foreground. So these would be the opportunities for the developer to actually dictate what should happen in the event it's about to be backgrounded or such. And you essentially have relatively tight limits here. So you are welcome to do some cleanup. You can write things out to disk. You can close network connections or save something elsewhere. But generally, if you take more than 5 or so seconds, iOS reserves the right to just kill you altogether. So this is not an opportunity to, for instance, reindex the database before you background it. You want to be quick and simple for the most part. And so if you've ever bought an iOS application that, when backgrounded, completely loses track of where you were in the game or whatever the program was, it's because one or more of these methods was not implemented or implemented properly. OK, other questions? Anything that'll help you stay on page today? No? All right, so here we go. So keep this picture in mind as we dive in. Let's go ahead and build an application from scratch. We'll start with a single view application, but let's make it a little more interesting than last week's name game of sorts and actually try to implement a sort of simulated ATM. So some kind of mechanism where you punch some numbers, and you effectively you deposit money into a virtual account. And we'll use this as an opportunity not just to refresh the sort of exercise we did last week with IB outlets, IB actions, wiring things up, writing a little bit of code, but also to introduce a model class, so we can actually have the M in MVC, so that these three pieces of the puzzle now start talking to one another. So again, if less familiar, do remember from Android or last week that we are going to try to adhere to this model whereby the controller, in the view controller, as Apple calls them, is really going to be the arbiter between models and views. And in a typical iOS application, you'll generally have multiple view controllers. So not just multiple views, but multiple view controllers. Indeed, in the Evil Hangman project, which again we'll talk about later today, this side is going to be governed by one view controller and one view, and this side will be another view controller altogether with its own view. And the reason being that this way you can have different classes really running the show on either side of that interface. One view controller responds to the actual game UI, the other only is dedicated to doing settings related stuff. So it's just a nice clean separation whereby one controller, we'll see, will hand off to the next. All right, so let me go ahead and propose that we implement a little something like this. It's definitely not the sexiest interface, but it's relatively easy to do via dragging and dropping. So I want to have a deposit amount at the top there, much like a calculator. So when I punch in numbers, I want to see whatever numbers I'm typing in with a $ prefixing them. I can clear to just change things back to 0, deposit to actually put that amount into my account balance down here. So we'll introduce a model object. We'll call it account to represent a bank account that will visually be displayed here, but itself underneath the hood will be stored in a dedicated object of type account. And somehow we're going to have to wire this up to some code. So when I push 7, some method in my view controller gets called. When I push deposit, some method in my view controller gets called. And similarly, once I've hit that button, I want to be able to talk back to from code to UI, or from code to nib, if you will, so that I can update the balances on the screen. So we're going to need outlets in one direction and actions in the other. All right, so let me go ahead and we'll use this template I just started making to go into, we'll call this ATM, and we will go into the nib file by default. Here we are, viewcontroller.nib. All right, so how to begin this story? Well, let's start off with something easy so I feel like I'm making progress. We can very easily click on the background here, go over here, change my background to something arbitrary like snow. The cute thing that some students recently pointed out is that Apple does have a few color palettes here. And this one in particular uses ridiculously humorous names or ridiculously non-traditional names to describe colors. So snow is really FFFFFF, but it's white really for our purposes. So let me click snow. Close the little inspector, and this is a little Xcode bug. I have to click away to actually see the effect. Now notice what happened here. When I clicked on this view here, notice that highlighted to the left are the objects, is the object that I just clicked on. So what we will see as we start dragging little widgets onto the view is that we'll start creating a hierarchy here on the left that we can then right-click on as needed. And just as a quick refresher, files owner, from which we'll do some dragging and dropping soon, represents what? So that's going to be the view controller. So this is a graphical representation of a class that will be instantiated elsewhere, but it's the UI mechanism via Xcode is going to allow me to control, click, and drag from left to right, just so that I can actually drag from something physical on the screen. But we recall from last week, you can even drag and drop from your actual code nowadays by splitting the view and seeing code and nib on one side or the other. All right. So let me go ahead down here and start off with a label. So I'm going to drag a label up here. And just to be neat and tidy, I'm going to use the little rulers, spread it out over here. I'm going to tell it to right align itself. Whoops. I'm going to tell it to right align itself all the way over. I'll go ahead and change the font size to be a little bigger. And I'm just going to leave that as, well, I'm going to make a mention of a little note to myself. We'll call this the deposit label. Enter, just so I remember which one that is. All right, and now I'm going to drag another one down here. I'll go ahead and spread it out over here. Spread this out over here. Center it. Make it a little bigger. And then I'm just going to arbitrarily call this balance label. Again, we're going to completely override these default values, but just to give us something to latch onto verbally. All right, so now we need some buttons. Round rect button is otherwise known as a UI button. This, frankly, early on has always kind of frustrated me in that these are sorted in the order in which the developer who made this part of the UI decided would be best. Quite literally, I think I was at WWDC last year and just very fortuitously sat down next to one of the developers who was working on Xcode, and it was this opportunity, one-on-one Q&A, where you could ask any technical questions you want, and they had a sea of like guys in blue shirts talking about iOS development. So I asked him, like, what is this order? He's like, oh, that's just the way I decided to make it. It's completely random, or at least prioritized based on things he cares about. So the search box is your friend down here. So if you type in button, and then it's also very user-friendly. Round rect button is just UI button, which frankly I would have preferred. All right, enough of that rant. So let's go ahead and just drag and drop this. Just like in most any WYSIWYG editor, you can do Command-C to copy, Command-V to paste. So I'm going to just drag these and line them up. So we have the beginnings now of an interface that's reasonably lined up. I'm going to double-click and type 7 here, 8 here, 9 here. To save time, I'm going to start clicking. And then I'm going to go here. And then I'm going to do one more row down here. And one more. We'll go down here. And then a little tedious, but I will do 4, 5, 6. And this too, frankly, we could do programmatically. So it's really just a trade-off as to what you decide is more convenient, either doing it once manually or doing it in code. This we'll call our clear button. This, again, will be 0, This, again, will be deposit. And just to make things a little more user-friendly, I'll click on text color over here, make that slightly green. Over here, I'll choose something slightly red. OK, so now we have essentially what I promised we would be creating. All right, so what comes next? I now have a UI. This is stored in a nib file. Underneath the hood, a nib file is just what? It's just an XML file. Who knows what it looks like under there? It's not something you're supposed to understand or should even open it or ever touch manually, but it's a textual serialization of what will ultimately be a hierarchy of objects. By hierarchy, I mean that there will indeed be a rectangular default view that encompasses everything, and then every time I dragged and dropped on top of that big rectangular view, it became a child of sorts. So you have a bit of hierarchy there where we have a whole bunch of children beneath view. Yeah?
It's funny to me, I kept looking for the ability to assign an ID to these objects so that I could in the code just say, instead of pointing by dragging, pointing in the code by just saying, the ID on the nib file is associated with this ID in my code, and I can now do everything instead of,
Yes, I think so. So in short, you wanted to be able to uniquely identify the things you dragged and dropped in your code. So yes, we can do this in a couple of ways. One, the way we did last week, where we manually drag and drop and create an IB outlet relationship so that you have a dedicated pointer to it. Programmatically, though, we can still uniquely identify these things if, in advance, we choose, for instance, the number 7. And then this is the attributes inspector, which is the third icon from the right up here. So if I start scrolling, a little bit buried under view here is the notion of a tag. There is an integral number associated with every UI view object, and a UI button, UI text field, almost a lot of the UI widgets we might drag and drop here are descendants of a generic UI view class. They all have tags, which is an integer. So what I would propose in this particular model is that we give this object an ID of 7, this object an ID of 8, this one an ID of 9, and this too is going to be a little tedious. We could do this in code, but recall from last week that if we do things in code, it frankly gets a little more, it's non-trivial in that you have to create each individual rectangle, position it at the point location, the XY coordinates that you want it at. So that's not necessarily the best use of our time. So tedious though this is, I can just verbally kind of stall as I do this. Whoops. Oh, thank you. Discard change. Discard change. Oh, thank you. OK, tag is 3 here. Tag is 2 here. Tag is 1 here. OK, this tag is going to be 0. A little bit of a corner case now in that 0 is the default tag. So we're going to have to be able to take care there. So I'm going to leave deposit and also clear at 0. But we need to be mindful of that. So as an aside, this too might strike you as fairly ugly design in that I'm arbitrarily hard coding in these numbers associated with buttons. It actually works out nice in that these buttons also have textual labels that correspond. But in general, if we were to do this programmatically and we were instantiating a whole bunch of UI buttons, this is a great opportunity for an enum where we could have a whole bunch of constants that represent numbers and then associate them there. Or we could just do it in a for loop so that we have an array that gives me the numeric IDs of these things a few different ways. If I had not done what you just guided us toward doing, and I clicked on a button, and that button sent an action message, triggered the invocation of a method, I could look at the label of a button and convert the label to a number, but that would just be a little messy. So tag actually works out to be pretty clean here, at least in this numeric context. Really good question. Yeah?
The tag has to be numeric?
It does. It is defined as an NS integer, which is just an int. Other questions? Maybe even NSU integer, unsigned integer. All right, so what comes next? I obviously don't have any code yet, so what kinds of methods might be advantageous to implement here? What kind of functionality we're going to need? What's that? So on click. So I want to be able to somehow listen to the key presses, and in the web world it's on click. Here it's probably going to be touch up inside, verbose, but same idea. All right, so I need to listen for those key presses, and there's how many different types of buttons here, at least if we want to bucketize these? It's kind of 3, right? There's a number, a digit, and then there's also clear and deposit and that's it. So it feels like maybe I want at least 3 methods that might get invoked, because I can multi-purpose one method. I can have one generic method for all of the numeric buttons and have him figure out what button was actually clicked. But I probably want a clear method and a deposit method. I could technically have one method with a big switch statement that figures out what to do, but that feels a little ugly. So let's go for 3 methods. So let me go into my view controller class. And in my interface, let me just start speccing this out. So I'm going to go ahead and say that I have one IB action whose name is going to be, let's just call it clear. And I can leave it for now as an ID sender. What is ID and what is sender going to be here? The button. So when a UI view is interacted with and a message is sent from it to one of your own implementations of a method, a pointer to whatever was touched is actually sent. Generically, ID is similar to a generic pointer. I avoid star, but it can also be nil. And sender is just the parameter name that Apple uses by default. So just to be clear, I could, if I know it's going to be a button, I could explicitly say, UI button star. And this has its advantages because then I don't have to cast potentially later if I care about that actual button. But let's stick with convention just for now until it gets us in trouble with this. So now let me go ahead and have a deposit IB action and also a digit IB action. All right, so these aren't implementations yet, so let's now begin to implement and see what else we need in this application. So I'm going to go to my M file. There's a whole bunch of distractions here, including this thing, a class extension. For now, I'm going to get rid of this just to clean this up. And we'll come back to some of the boilerplate code there. But let me paste in these placeholders and just start to implement them with some to-do placeholders. And now down here, let me open this up. And then down here, we'll do the same. And then just for kicks, let me go ahead and do an nslog digits, just so I have a little something going on so that even before I know what I'm doing, I'm going to go ahead and have methods called as little sanity checks. All right, so I'm going to go ahead and compile and run this with Command R. Succeeded, so no syntax errors. My simulator should spawn. And let me pull up the debugging window in Xcode in the background over here. So in the bottom right is where we should see some output. And yet, nothing seems to work. Why? What? Oh, drag and drop? What about?
You gotta attach the
Yeah.
outlet to the action.
Good. So we have to attach the outlet, well, not the outlet to the action. We need to attach the outlet in code to the UI widget. But we also need to do one thing before that. You've seen all the code I've written. We need the outlet itself, right? I didn't even declare any outlets, just some actions. All right, so back to the drawing board. We go to the H file here. And let me go ahead and start declaring some properties, right? Because properties can then be declared with IB outlet keywords, which will then allow me to drag and drop. And to be clear, let's go into the nib. Let's get a little ahead of ourselves. Here in the nib, I want to have an outlet from the file's owner to the number 7. So I start dragging the line. It hovers, all is well. I let go. And then what outlets do I actually have? All I have is a view. This is not something I defined. This, in fact, is inherited from the view controller's parent class, UI view controller. And there's already a minus sign suggesting it's connected. What is the connection here to? What is view? What is this outlet for?
That's the main view.
Yeah, so it's already a pointer that we get for free out of the box that's pointing to the top of this hierarchy. So the view controller itself needs to somehow know what rectangular stuff to show on the screen. So the template that we got from the single view template is already hardwired to have that particular pointer wired up. So that's why we don't even see it in our code. It's inherited. All right, so over to the .h file. Let's start defining some properties. So I want a property. I'm going to come back to the parentheses in a moment. This is going to be an IB outlet, and it's going to be a pointer to a UI, let's say, what does it need to be? Oh, and actually, I misspoke earlier. I latched onto the wrong word. So we don't want, the problem that before, whereby we clicked buttons and nothing actually happened, was because indeed, we hadn't done the linkage from buttons to actions. I said outlets instead. So actually, let me roll back, and we'll delete about 1 minute of videotape, and we'll go back here. So the problem was that I can click all I want. There's no message being sent to the file's owner. All right, I got ahead of myself. So let me go ahead and control click on the 7. And now notice I have a whole bunch of events that I can listen for. And frankly, I don't really remember offhand which is the right one for buttons. So I'm going to go ahead and go take a leap of faith and instead just hold control, click, and start dragging all the way over to Files Owner. It wants to connect there, so I let go. And now I see my list of IB actions, which do already exist. So which one do I want from the 7? All right, so digit. I'm going to go ahead and choose that. And now here comes some tedium. Had I thought of it earlier, I could have created one button and then copied and pasted that button, and it would have retained this IB action relationship. But it's OK. I can fill the time with a few words, and we're almost done. That's a good question. Whoops, that's a good question. Let's see. Wow, nice. Yes, you can. All right. So now let's do a little random sanity check. Control click here, and OK, that one worked. 2. No, if you multiple select, it only chooses the topmost elements. All right. Just lost another 15 seconds of tape. So the 0. All right, so now let's control click. OK, so that worked, and let's control click the 3. That worked. OK, so I think we're good now with the digits. Now let's do clear over to Files Owner, and obviously choose the clear event. Deposit, the deposit. And now if I right click over here, notice that I indeed have clear mapping to one button, deposit mapping to one button, and digit mapping to a whole bunch of others. To remove these, you can just click any of the X's. And these circles, again, are just a more obvious way of dragging and dropping if you forget the control click trick. All right, so now let's save. Command R. Build succeeded. Now I have the UI. Let me pull up the debugger window with that little button there. Click 7. Good. 8. Good. 9. Deposit. Clear. OK, so it seems to be working. Now, the program doesn't do anything interesting, but at least the connections are now up to date. All right, so let's go and do the, let's say, clear method. What needs to happen when you click the clear button? All right, so we want to clear the label. So we want to somehow be able to talk to the label and then actually update the display there. All right, so this does suggest, we can pick up where we left off earlier, it's probably time to have an outlet here. So I need some mechanism from code to UI. So I'll say property with some parenthesized list in a moment. This is going to be an IB outlet, and it's going to be of what type? Anyone recall? UI label. Star, and we'll call this the deposit label. And let me copy and paste this because we'll probably want 2 of them eventually. So we'll do this, the balance label. All right, and now this parenthesized list. So we have a few options here. What are some of the keywords that probably belong in these parentheses? Non-atomic, mostly because we're not writing any kind of multi-threaded code here. Read, write, and weak. So weak we'll spend a little more time on in the future talking about when we dive into a bit of memory management, at least what details remain for iOS 5 programmers. But for now, know that weak could have been weak or strong or copy. So these are really the 3 candidates now, and or assign, but assign is definitely not right here for pointers for the following reasons, or let's consider these heuristics. Assign would be the attribute to use if it's pretty much just a primitive. It's if an int, a float, a char, and so forth. Weak and strong and copy are relevant when you actually have an outlet to a property to a pointer. Weak is something you will generally choose now when the pointer you're creating is going to point to something that you yourself did not instantiate. So you did not call alloc. You did not call copy. You did not create that object. And indeed, that's appropriate in the case of UI labels, because who really seems to be responsible for creating them in this story? The controller, and then even more precisely, the nib, right? So they're somehow serialized in the nib. So the unserialization of that XML file is somehow going to result in the reinstantiation of these objects, or the actual instantiation of these objects. And we didn't really do that, certainly not directly by calling alloc, so weak is fine there. Someone else will keep this pointer valid in memory. Strong will apply when we ourselves call alloc is a reasonable thumb. And copy will be involved when the pointer in question is generally to a string or to some collection container that you actually want a genuine copy of, not just the pointer itself. But again, more on this probably next week. Read-write simply says it's going to be read-write. But what do these really mean? These are hints to what implementation detail of properties. Yeah, the setter and getter. So there were two main motivations for introducing properties in the first place. One, you can automatically synthesize, that is, generate getters and setters, which is a huge plus versus something like Java, where it's a lot of boilerplate copy-paste code. So these attributes are instruction to the compiler as to what type of getter and setter to actually generate. Right? In the case of non-atomic, or the opposite, atomic, the setter that would be synthesized in this case is going to have no special locking mechanism, no semaphores, no means of excluding other threads, and that just means you save a few CPU cycles. If it were instead atomic, there would be more complexity to the setter, and that's what would be generated. Read-write, if it's read-write, that means what happens when you do @synthesize? Getter and setter, and then read-only gives you just the getter, not the setter. So that's pretty helpful to know. And then weak is the story we just told, but more on pointers, more on that feature of pointers in the weeks to come. All right, so now we have two outlets. Not quite sure what I'm going to do with them yet, but I do know that I probably need to wire them up. Just for the sake of doing something different, I'm going to go ahead and open the little butler icon up here, which shows the assistant window. And then over here, I'm going to go ahead and choose the nib file. A little keyboard trick for what it's worth is if you hold Option and click a file, it changes what's in the right-hand pane, or you can, frankly, very tediously choose from the hierarchy that generally appears up here. Or if you just click here, it changes what's on the left. So nice little shortcut. My screen resolution here is only 1024 or so today, so it doesn't look the prettiest, but I'll make a little more room. That's not really helping here. Let me open up the nib with Option click. And then over here, what do I want to do? I'm going to go ahead and, just to be different, I'm going to click on this thing and go to the deposit label. And then I'm going to go from this thing over to the balance label, and that achieves the same effect. And it's a lot prettier on a bigger screen. Yes?
The property, is that what gives us the ability to use dot notation?
Yes, sorry, we didn't finish that story. Properties, in addition to the automatic synthesis of getters and setters, you get the syntactic sugar of dot notation, which is...
You don't have to write that generates the synthesis for us.
No. So this actually gives you the dot notation capability. If I now want the other feature, the automatically generated getter and setter, one step still remains for me. I have to go into the M file, and then inside of my implementation, I have to actually synthesize those things, which in this case are called deposit label. And with an equal sign here, I'm going to have it automatically create for me an instance variable called the underscore deposit label. And then here I'm going to have it do the same for balance label. And this equal sign and the underscore is just a convention, so that when these instance variables are automatically generated for me along with the getter and setter, I can still access them directly in code, and it's just a little more clear by convention that the underscore means it's an IVAR and not a local variable. Not this, it would be self arrow, self hyphen angle bracket to access it. But you don't need the self and the arrow. You can just mention it on its own. It will be in scope. Yeah?
As opposed to rewriting what's in the header and to do methods inside the actual file and along with the synthesize, is there a quick way to say, give me all the stuff that I have in the header and give me...
Oh, for synthesizing?
No, for instance, the clear, the deposit, you wrote these methods, you wrote it in the header file, the actual declaration, and then in here, the actual methods. Is there a way to say, just give me them in there?
Oh, a good question. Is there a way to declare your methods in the .h file and then have this boilerplate code automatically generated for you? Not to my knowledge.
Actually, there is one.
Is there?
Go to the butler icon and
Go to the what?
go to the butler icon,
Okay.
and on one keep the URL, the view, and the other the code, and just try to drop the rectangles. Then it will automatically.
Wait. Try to do the what?
Go to this nib file in one screen. So open a nib file.
Okay.
And like suppose go to the button, like the number 9 or something.
Okay. Yeah.
And just drag the code to the code, the controller.
Oh, yeah.
In
Oh, you were talking about, though, actually generating the stubs, though. Oh, okay. So we're doing.
Drag it into the,
Oh, yes. You're okay.
Right to the property and sensors.
That's right. I actually never make use of this feature, but let's see. This will give you, yes, there we go. So this will give you some of the skeleton code if you want. So you can do it a little less manually than I did. Okay, good call. All right, turn the butler off. Go back to the M file. Okay, so we were about to implement clear. So now we should probably start giving a little bit of thought to the design of this program, right? We've got everything wired up. We have the framework in place for the app, but now we need to actually model the notion of an ATM. So I proposed earlier that we implement the notion of a bank account. And for now, let's keep things super simple. A bank account is just going to have a balance, and it's going to be an unsigned long, just so we can have lots of money in the account and never go negative. So I can do this in a few different ways, but really I just want to create a new class, I think. So I'm going to go to File, New, and then I'm going to do File. And now I have a whole bunch of templates for the file, not for the whole project. Beware being under Mac OS. The templates will be a little different. Let me go up to Cocoa Touch. I'm going to choose Objective-C class and click Next. I'm going to go ahead and call this account, capital A. By default, I'm being encouraged to have it descend from NS object, but I can choose other things or anything I really want to type in there. But NS object is fine. Let me click Next. I'm going to go ahead and make sure I'm in the ATM directory. I'm going to go ahead and create. And then over on the left-hand side, notice I just got 2 files automatically generated. I'll drag them up to the top. And here's what I've gotten for free in my H file, just the beginning of an account. Then on the account.m, I have the beginning of an account's implementation. All right, so I want to have a implementation here of an account. So we need to keep around this unsigned long. I can do this in a couple of ways, but properties tend to be pretty nice. So let's just start it off as a property. I'll come back to the parenthesized list, and I'm going to go ahead and do this as an unsigned long balance, though we could have a few different options there. And I'm just doing dollar amounts, no cents. And now for this property, what attributes are appropriate if I'm going to synthesize its getter and setter? Assign, atomic. Non-atomic is fine because there's no other thread here. And read-write. So again, the rule of thumb helps us here. Assign pretty much always for primitives, so that we just get a copy of one of the input to the IVAR. Yeah.
I understand that the atomic property is not necessary for single-threaded code, but is there a particular reason why, affirmative reason why to choose non-atomic?
Just the very marginal performance benefits of not having the thread-safe code generated for you. And for the camera, why bother with non-atomic? Because the default would just be atomic. Could save me some keystrokes. Just saves you some CPU cycles by not having that code generated. All right, so now over here in the implementation of the account, I want to go ahead and just synthesize this thing. And to be honest, I don't really even need any methods associated with this thing. It's probably sufficient just to have a getter and setter. So I can create instantiate an account object, initialize it, but we'll come back to that in a second. And then a getter and setter are going to be given to me automatically. So I already have 2 methods effectively. But what about initialization? When I allocate and then initialize an account, what kind of initialization should I probably do for good measure? Yeah, probably set it to 0 minimally. So I'm going to go ahead and in my implementation here, I'm going to go ahead and declare an init method, which will override the parent class's implementation thereof. So for good measure, I should get into this habit. So if self super init, and if that returns something that's non-nil, then I can go ahead and do, let's say, self.balance gets 0, and then I can return myself. And this line here, this is invoking what method, even though it looks like a very simple property assignment? It's this. Oh, okay, good. It's getting easy. Okay, so just to be clear, syntactically, this is really the same as set balance : 0, and it's just a little nicer to type. But that's all that's happening. The same message passing that we talked about 2 weeks ago when we first dove into Objective-C. All right, so I don't strictly need to declare init in my header file because it's just overriding the parent class. So I think we're kind of on our way here. So let's go into View Controller. And we were trying to implement the clear method, but I don't really have anything to clear here. So where might it be appropriate in this application to actually instantiate an account object? Sorry? Okay, so let's see. Let's scroll down over here. View did load. All right, so view did load. Do any additional? I don't remember what this is, so let me hold Option, click on view did load. I get a little cheat sheet called after the controller's view is loaded into memory. So that could work. So I could start putting some code here, and let me do that, and then let me issue some caveats. So here we go. What is it going to take to actually create an account? So create account, and we'll do self.account gets account alloc, and then done. What else should I probably be doing here? Init. So again, very common paradigm in iOS. You call alloc. You almost always call init, or at least a method whose name starts with init. There are sometimes more specific ones. So it's not liking this for some reason. Self.account. What assumption have I apparently made? Okay, so I minimally need to import the account header file so I know what is in what an account actually is. So let's do that. Let's see if Xcode's happy now. Closing. Oh, okay. Okay, that fixed that error, but Xcode's still yelling at me here. There's no property called account. So I made properties in the account class, but let me go into view controller, and I'll also clean this up in a bit. Let me go ahead and set a property. We'll come back to that. This is going to be an account, and I'll just call it account. What kind of attributes do I want for my synthesize getter and setter? Non-atomic, read, write. So those are pretty easy usually. And strong. So in this case, because I'm going to be doing the allocating, I really want to ensure that I have a strong reference, so to speak, to this object. And what that really means is that the memory that's allocated for this account won't accidentally be reclaimed on me without my as a surprise to me. That memory will remain resident in the heap for me without being reclaimed. Whereas if I declared it as weak, it's possible it could get evicted without my realizing it. So this, as an aside, and we'll come back to this in a week or so, this all has to do with how memory is managed underneath the hood. It's through a technique called reference counting. And long story short, when you allocate an object gets a reference count of +1 by default. What happens then is that if you specify strong, you're effectively doing another +1, so that even if the original +1 is decremented to -1, the total references that you have associated with the object is still a non-zero number, which means the memory will not get reclaimed. And the -1 happens because of this new technology called ARC, automatic reference counting. So if a pointer goes out of scope and it's therefore, the object it pointed at is therefore a candidate for reclamation, it's not going to get reclaimed. It's not going to get garbage collected, though that's not quite the right word here, because I have a second +1 that I performed by mentioning strong in this case. But again, more details in a week. Yeah?
Does that mean that your UI labels can be retaken back up to memory since they're weak associations?
More concretely, the fact that my IB outlets are weak, they can become nil and their memory can be reclaimed, but that will only happen when they go out of view. And when they are placed back into view, as by having the nib reloaded, then those pointers will be reconstructed for me. All right. OK, so now I have a pointer to that. I just need to go ahead and synthesize the account. So let me do this inside this block. Synthesize account gets underscore account. Again, the underscore is not strictly necessary, just a convention. And now I can hopefully have this initialization happen in... I can actually now initialize this thing, view did load. Now that red exclamation mark has disappeared. And now I need to somehow display this account balance. And we can do this in a couple of ways, but well, let's try to do this. In this line here, display initial account balance. And I'm going to retract this later because we can do this elsewhere. But how do I go about talking now to my nib, or really more specifically to my UI, so as to update that label so that it doesn't say the very generic balance label, it instead says $0.
We have a pointer to that label.
OK, so I do have a pointer to that label called a balance label. OK, so .text gets, how do I want to do this? Account, so I could do this here, account.balance, oops, Whoops, and then I need self.balance. Yeah, so this I'm just being kind of silly here. So this definitely won't work. So I need some kind of string. So it turns out there's some convenience methods we can take advantage of here. And there's a few ways to do this. NSString, we can do string with format, which is a very common one for formatting strings. It takes an NS string as an argument. I can then do literally $. I can then literally do a placeholder here for a decimal digit or digits, and then I can go ahead and close that and then pass in a value of what? Yeah, and actually, because this is a long, unsigned long, I should really do that, LLD. And then close this, semicolon. So now, Xcode's not yelling at me, and on the left-hand side, what have I done? So self is a pointer to myself, the current view controller object. It has a property called balance label, so self.balance label gives me a pointer to that balance label, which is of type UI label. In turn, .text gives me what probably? The text value of that label. So in the context of HTML, this is like the .value property of certain DOM elements, input elements. .text is going to be a pointer to an NS string. So on the right-hand side, I am indeed dynamically allocating an NS string. That call is going to return a pointer. It's going to assign that address to the .text property. So in the end, I should have a formatted string that's $number, $0 by default. So let's go ahead and see this if it compiles, and does not. So unknown type name account. What have I done wrong here? This one's actually pretty easy. It's in my H file. So now that that's there, I don't technically need it in the M file as well, but it's not bad to put it there as well if both files use it. So let me try recompiling. And realize Xcode doesn't always dismiss its redness sometimes. You have to try recompiling. OK, so that worked, and voila. $0. So we're kind of on our way. Now, I should disclaim that this isn't necessarily the best place to put this in view.didLoad. Let me go to viewcontroller.m. So we put this in view.didLoad, and this is, again, the method that's called when the view is loaded. But what can also happen to views?
Well, they can go out of view and then come back.
Exactly. They can go out of view, and they can then get evicted from memory. So let's see. View.didUnload is supposed to be the method that's called when something is evicted from memory. And let's see if we can get the simulator to cooperate here. Just for kicks, let me go ahead and do an nslog of quote-unquote view.didLoad, just for diagnostic purposes here. And then just so I know what's going on, I'm going to do it here too. Oh, view.didLoad, and this one I meant to say view.didUnload. So I can see on the screen when these methods are being called, and that's not how you do this. There we go. OK, so a little sanity check. Let's rerun the code now. Watch the debugger in the bottom, and view.didLoad was called. Let me try backgrounding the app. OK, not so bad. Let me go ahead up here and simulate memory warning. It didn't cooperate this time. OK, so in this case, that would have been an amazing demo, but it didn't work. In cases where there is insufficient memory in the device and your view is not even within view right now, and actually in this case, because there's only one view, there's actually a pointer that's keeping it resident in memory, which means it's not getting punted. In the events like in Evil Hangman, where you will have two different view controllers, and indeed two different views, only one of which is ever visible at a given time, those views are absolutely candidates for eviction from memory. And even though this might not happen all the time, especially if there's plenty of RAM and it's a pretty small application, it's not very memory hungry, in the simulator, as I just did under the hardware menu, you can simulate low memory warnings, as might happen if you've got a GPS app running, you've got music playing, your emails checking, a lot of apps that are doing things in the background might be consuming the iPhone or iPad's memory. So in the cases where that happens, views can be thrown out of memory. And this is OK, because in the MVC paradigm, there should be nothing important stored in view objects. They're really meant to be ephemeral objects, because the real interesting data should be stored where? In the model. And maybe you have copies of it in the controller on their way to the view, but you should not be storing one and only one copy of interesting data in the view. So absolutely can stuff be punted from memory. So even though in this case, we actually get lucky because this app is so simple, and we have... Let me pull it up again. Because this app is so simple and it only has one main view that's not being thrown out of memory, it could be. So really, writing initialization code in view did load or view will appear, which is a similar but slightly different method, probably isn't the best practice in general. Certainly not for something like evil hangman, which will have multiple views and controllers. So, yeah.
Why did this one not unload? I mean, even though there's only one view, if you simulated a memory warning, why did it not unload?
So in this case, the view controller has a strong reference, the outlet to the view. And so because the view controller is resident in memory, its own pointers remain resident in memory. So it's not going to evict those views. By contrast, if there were multiple view controllers and one was not literally in view of the user, that could be evicted from memory.
If there's an app with only one view, it's never going to be unloaded?
Oh, good question. I'm wary of committing to a never statement here. Let me give that some thought and answer intelligently rather than with 50-50 probability. All right. Okay, so where else could we put this? Well, a reasonable candidate. Let me go back in here, and I'm going to go ahead and just delete view did unload because I'm actually not going to care about any kind of cleanup here. View did load. Let me just scroll up here, and let me actually do this. Void init with, come on, oh, that's why, ID, init with nib name. So init is really the most generic type of initialization method, but there is a more specific one that's actually already associated with the UI view controller class, because what method, after all, is the app delegate using to create our first view controller? It was init with nib name bundle. And in this case, we saw it a moment ago in the little dropdown. So this is actually a pretty good candidate for initialization. Because why? Well, my view controller is already, by definition of the app delegates implementation, calling this method. Now, I can't just override this method's behavior and plug in just my own. I still need to call that parent class because there's presumably some important initialization that's going on. So again, I'm going to do if self equals super init with nib name, and then I'm going to literally pass in the same arguments names, really just passing the buck to the parent class's implementation. But if that returns a non-nil pointer, here I can put my initialization and then eventually return, return self. So I'm going to go ahead and steal this same initialization code from here, put it up here. And now at this point, since I don't really have anything that's view specific, I can even get rid of view did load at this point. Again, because this is a fairly simple application. So now if I go ahead and run this, build succeeded, simulator should run, and what did I do wrong? Self account, self balance label here, init with nib name, init with nib name bundle. What did I do wrong? Sorry? If self super. Quick sanity check. Whoops. NS log. That's what happens when I do things on the fly. 1, 2. Okay, that's not the error. Self.balance label. Set the value of balance, but my property should have an outlet wired up balance label.
If self.account.balance was nil, would it leave the label or would it say nil in there?
Oh, that's why I did this. Damn it. Okay. Okay, sorry. Let me slightly, this is what I wanted to do. Initializing the account. Okay. Initializing the account, I want to happen once and only once, when the app actually loads. If the goal is to simulate an ATM, it'd be nice if the account balance starts at some value, but then does not reset itself to 0 just because we ran low on memory, because I got a phone call or a text message and I backgrounded the app. Then I came back to deposit more money into this imaginary ATM. However, as perfect. This code is not crashing, but it doesn't appear to be working right because self.balance label at this point in the story is indeed nil. Why is that? Well, the view has not been loaded. What does that really mean? It means the nib has not necessarily completed being deserialized and then displayed or loaded into RAM with the UI view parent object instantiated and all of those children, all of those buttons and those two labels we created. So at this point, if I do want to actually update the UI, I do have to wait for the view to load. And so I can now restore view did load from earlier, move my display code inside of view did load, so that at this point in the story, I can trust that my outlets have all been assembled, and that was the effect that we were aiming for. So not a bad thing to have tripped over, but that's the actual technical reason. Yeah?
Because the only thing that you really shouldn't put in that onload thing is any instantiation of anything.
The only thing you shouldn't, state it once more?
Stuff that you should not put in the view did load.
Correct. You should not put code in the view-related methods that you only want to execute once, because views can be loaded, unloaded, appear, disappear. So they are really meant only for the V in MVC. Anything that pertains to the C or the M, the controller or model, really belongs in higher level initialization routines, like in this case, init with nib name.
Which runs after the view.
Before. Before, right? So, and you can infer that from the app delegate. The app delegate first allocates the view controller. It then initializes it, and then not till 2 lines later does it actually make the view visible, which has the effect of triggering the actual instantiation of all those view objects.
So in this case, then, if our view gets taken away because it's below memory, when it recreates, it's still already got that initial balance.
Correct. Correct. So yeah, to be clear, the reason I wanted to put my account balance initialization to 0 in the init method is so that it happens once and only once. And it's only once because here's the code that calls that method once and only once, whereas the views might come and go, even though in the simulation we just did, they didn't, because there really is only one view in question. But odds are you can trigger this behavior with Evil Hangman when you do have 2 views in question. Specifically, when you click a button, flip it around to see the settings, and at that point in the story, the main view controller is still loaded in memory, because this flip side thing, as we'll discuss later, is a modal window, whereby the other view and view controller might very well still be in memory, but the view could be evicted in the background. Yeah?
You say once and only once it gets initialized. If the power drops or something along those lines, and you freeze and you open up the application again, it will re-init that object, right?
Correct. If the app wasn't just backgrounded but was terminated, init will get loaded again.
That's where you would use the database or something.
Correct. So init methods is really for, let's oversimplify with anything related to M or C, but any of the view methods, view will appear, view did appear, view will load, view did load, should just be related to V stuff, view stuff.
Why do you think they hide that method by default? Would they want maybe the data classes instantiated in the app delegate first, because that's a once?
That's a good question. This is so the question for the camera is, why did I not have some skeleton code for init with nib name bundle? Short answer is it could just be slightly arbitrary. Frankly, if you really think hard about Apple's templates, they're not always the cleanest. It's whoever's whim was when they were writing this. But it's also a bit of a religious thing. Most people frown upon putting app-specific code in the app delegate itself, except for the most basic low-level initializations, simply because your controllers that actually interact with the user probably are the ones that should be running the show if you're going to adhere to this MVC paradigm. But you can put that kind of code in the app delegates. And indeed, some of Apple's own source code examples do put a non-trivial amount of code here. So it's really just a design decision. In this case, I would argue a clean design here is because you're configuring one and only view controller, because you're making it the so-called root view controller, and then effectively are passing off control of the application to that sole view controller. It's pretty reasonable to isolate your code there, because that is indeed to whom you're handing off control of everything. And it's that guy that's going to need pointers to any of the models that you instantiate. The models probably shouldn't be instantiated here. Other questions? All right, so we didn't actually implement key press. We didn't implement deposit. What I think we'll do right after break is pull a little pre-baked cake out of the oven and look at how we might implement those things. Then we'll dive into some more graphical things with gestures and storage thereof. So let's take our 5-minute break. All right, we are back. So here is a pre-created complete implementation that almost identically mirrors what we just did on the fly. Here comes a 1, 2, 3. So that's a feature that's now implemented at this. If I click clear, we get that behavior. 1, 2, 3, deposit. And notice the money ends up at the bottom. If I add one more dollar to this and then click deposit, should go to 124. And seems to be a working implementation. I can background it. I can then pull it back up front. Seems all to be well, at least at first glance. So let's dive quickly into how the remaining methods were implemented. So here's clear. It's actually relatively straightforward. I, one, need to update my model if I'm clearing the account, or rather if I'm clearing the amount string. So in addition to the balance, I also had this thing here, self.amount, which notice up top is apparently a synthesized property of the view controller. And if I look in the H file, notice that I have this, an unsigned long. So in addition to my model, which includes a pointer to an account object, which itself has a balance, I also need to somehow keep around a piece of data that's the numeric representation of what I see visually here. In other words, what I see up here, I need a variable, an IVAR or a property equivalently, so that I can represent that number, so that I'm not just relying on the view to store it, but I myself have my own copy. So if I really wanted to be proper here, I could create another model that somehow represents the current deposit in progress and wrap it, but it just felt like overkill. I really just needed an int to actually store the number that the user has currently typed in. So I kept things simple and only introduced a model for the balance, which is meant in theory to be a little more persistent. So if I look at the view controller, here's what it means to actually clear the amount. I simply say self.amount gets 0. And then what I realized after writing this whole thing from scratch is that I was kind of copying and pasting a lot of code that was talking to my outlets and updating the labels on the screen. So I outsourced it. I factored out a bunch of view-related code, created my own method called show, and show simply does the updating of the UI. So let me fast forward here, and it does two things. It updates the balance, and it updates what the user, and it updates the deposit there with 2 LLU placeholder strings. So that's all. I just realized that I was copying and pasting that a few times. All right, so if I scroll back up here, how do I implement deposit? Well, when I do deposit, I want to update the model's balance on the left with the addition of the new amount, which is stored locally. Then I want to go ahead and clear the input, much like a calculator, and then show the updated result. In this case, updating two things. Another motivation for that separate method. Now, digit's a little more interesting. It's kind of a fun little CS 101 method. And before I reveal the secret sauce, when you type in a 1, and then type in a 2, and then a 3, there's actually slightly interesting arithmetic that has to go on there, right? Because you have to keep shifting the places over. And if you think back to grade school, if you type 1, it's in the 1's place. But then if you type another number, the 1 has to become the 10's place. And then if you do it again, the 10's place becomes the 100's place. So this is a nice opportunity to effectively shift these numbers by multiplying by 10 every time the user types in a number. So sure enough, if I scroll down to digit, I have to do a couple of things. One, because I have chosen, for better or for worse, to just have a generic argument in the iOS paradigm of type ID, whose name is sender, but I want to access the tag that I put on that button, I need to cast this very generic ID pointer to a UI button, or at least a UI view, which it descends from. So this first line of code is just a simple cast of sender to UI button star. Frankly, I could avoid that altogether by just changing the signature of this IB action. And frankly, I go both ways sometimes. I actually have started to not cast, because it just seems like wasted time, and just change the method signature to expect a specific pointer. And then here's the interesting arithmetic. I want to update the amount, the running total in the top of the screen, to be the current amount times 10 to shift the current number over to the left, plus b.tag, where b.tag very nicely is an integer. And it's the integer associated with that button, so everything kind of works out nicely. Now, in a more interesting application that just doesn't coincidentally have numeric buttons, I could figure out that b.tag really is just a constant. It's 1 or 2 or 3. I could then look up that constant in an array, or I could treat it as an enum, so that there's some kind of mapping between this very arbitrary tag integer and what I actually care to represent. But it was very fortuitous that I care to represent numbers, so I'll dual purpose tags. Again, a poorer design would have been to ask the button for its label and then use that value, cast it back to an int, or convert it rather, string to an int. That just felt like sloppy to do it that way. But it's possible. All right, so here's the show method. Scrolling down, should auto rotate. I simply hard coded this so that one, it would only support the normal way up. And then here we have view did load, view did unload. And that, I think, is the last of those details. We pretty much implemented everything but those two remaining methods. So a word on design of code. So we've thus far had this very common paradigm of putting properties, putting method declarations, putting IVAR sometimes in the header file. This isn't strictly necessary. In fact, really what belongs in a header file, typically, especially in a multi-class object-oriented environment, is really only stuff that other classes or maybe other developers should actually care about. So we don't need to put all of this stuff here. Notice a couple of refinements we can make that is becoming increasingly common in Apple's own templates and such. We don't need these curly braces because we have no instance variables, at least not ones that I'm explicitly declaring. We do have instance variables, though. Where are they coming from? The properties. Because of @synthesize, besides giving me getters and setters, that's also giving me the backing store of an instance variable that's named whatever I put after the equal sign, if I have it. So I don't need those things, but that's really just an aesthetic detail. You know, technically, I don't need to declare any of these in what's effectively my public API in my header file because I'm the only one using them. So I could actually not include those altogether, though as your file grows, it's kind of nice to have a succinct summary of everything that's in there for your own sake, for your partner's sake, in multi-user, in multi-programmer environments. But it doesn't strictly need to be in the header file, at least, which suggests that other people would see it. And then these properties, too, are really only for my own benefit. These aren't public properties that others are meant to use. So realize that an increasingly common paradigm is to do this, to really have minimal content in your header file. So I'm just going to literally whittle this down to almost nothing. And then in your M file, to actually restore the boilerplate code that was there, that very early on tonight I deleted and said we'll come back to that, where I can redeclare interface, and the interface in question is view controller. But I already did this in the header file, so I can't quite redeclare the same class, but I can do what's called a class extension. So this was a feature I alluded to a couple weeks ago when we talked about categories in Objective-C, whereby with this feature called categories, you can take an existing class and you can add to the methods and the properties that it has. If you're quite savvy with JavaScript, this is akin to modifying the prototype property of a JavaScript object so that you can add features to the date object or the string object in JavaScript. So same idea here with categories, and it's nameless in that you don't bother even putting a name here. Historically, people might literally write something like private. This is my private category, but even that is not strictly necessary with Objective-C 2.0. So I can actually put these things here. I just hit copy and paste. Notice that I can put inside of my class extensions all of those properties as well as those method declarations. So I still have the information. I have the self-documentation here of those declarations, but I'm not exposing it to anyone else. Now, frankly, this is kind of a wasted, this is really just a thought exercise because this is such a small application. There's no other classes in question. The view controller is kind of the guy in charge. But in terms of making more sophisticated designs and really encapsulating methods and data that you don't want other people to see, or you certainly don't want to encourage them to try to use if it's really not for them, this is an increasingly common paradigm to use class extensions in this way. Yeah?
So in the world of Java, all private methods and variables go here,
In the world of what?
like Java.
So in the world of Java, sort of. So Java only has .java files, and the interface is declared in the same type of .java files. It's not quite this, well, this is one way of approximating the idea of privacy. So Objective-C does have private instance variables that cannot be accessed by members of other classes. Objective-C does not have private methods, even though I have relegated these methods implementation and declarations to my .m file, thereby not allowing someone to sharp import them. If someone knows that I have a deposit method, they can still pass that message to my objects. So this is one way of taking advantage in Objective-C of otherwise undocumented features. You can't stop another object from passing you messages. Indeed, that's one of the features of Objective-C. You can pass messages even to nil, and maybe we'll get back a response. So privacy is not really enforced, is not enforced for methods. Okay. So in short, either approach is fine. If this is kind of a lot of sophistication when you're really just learning Objective-C and its syntax for the first time, by all means follow the earlier paradigms, what you quite often see in books, putting declarations and properties and such in the header file. But just realize these refinements are possible, especially as you think toward your student choice project when perhaps you'll feel all the more comfortable with the language. Any questions about our ATM? Yeah.
I hesitate to say this, but I'll just say that
Okay.
when I was working in the header file over the weekend,
Mhm.
I found myself declaring private variables and then also declaring them as properties.
Okay.
And then also synthesizing them, and I was like, I don't know what I'm doing here, and I was
Okay.
confused. So I just ended up with private variables, and I didn't synthesize anything, and I thought, I was like, I'll get back to that. But,
Okay.
is there some, does that make sense? If any, would there ever be a time where you would declare a variable and then also make it a property below that? I mean, am I just doing it wrong?
Good question. So for the camera, so your experience as you sort of learn your way through all of this, you've been declaring some private instance variables like I just arbitrarily did here. Then you're also declaring properties in your H file, and you are or sometimes synthesizing, maybe not. So you're not doing it wrong. You're just kind of caught in this awkward transition period from older Objective-C paradigms to newer. And it doesn't help that there's so much documentation in books and even Apple's sample code that is still in the older state. The increasingly common today is to see what we just did with the ATM examples, whereby you don't explicitly declare really any of your instance variables. There are a couple of exceptions to that. You really just instead declare properties, and then you use @synthesize. Now, rewind 6 months ago in Xcode 4, this is maybe TMI, but in Xcode 4.2 there was a bug in the debugger, GDB, whereby if you did not explicitly declare your IVARs, even though they would be automatically generated for you with @synthesize, the debugger would not know about them, which made debugging almost useless when you're trying to actually see inside of objects. So that then motivated, also probably in online examples, to do the IVARs explicitly and do the synthesize and do the properties, but that was a programming error in Xcode. So short answer, get into the habit of properties, get into the habit of synthesize, and in my implementation of Evil Hangman, I actually do use one private IVAR because I wanted a C array. I essentially wanted a little cheat sheet, an array that would let me know which letters have been used. And I could use an NS array, but I just didn't want the overhead. I really just needed a little cheat sheet, and so an array of size 26 in my case was a nice thing to have around, so I put it in an IVAR. Now please, let's not have 100 implementations that have an array of size 26. This is just one approach, but when you want that fine-grained control, it's still helpful to declare those instance variables. Those two can be moved to class extensions, because it's also a little weird, frankly, in your header files, which other people are meant to sharp import, that you would actually tell them what all of your private variables are, even though the runtime will prevent them from accessing them. It's just this should be on a need-to-know basis. So class extensions, like we just did, also helps people hide what are functionally private and also make them aesthetically private from prying eyes. So in short, it sounds like you're on the right track, and even honestly, the recommended books, even though they're updated for iOS 5, the authors have cut many corners, and a lot of the screenshots were not updated since iOS 4. So they kind of bang those out quickly, which doesn't help learning the stuff. All right, so how about a little something like this? Let me go ahead and open up some prefabbed code in just a moment that allows us to start playing with gestures. So if you have an iPhone, and frankly if you have an Windows phone or Android phone, you're generally familiar with these increasingly common paradigms of pinching, of spreading your fingers, of dragging swiping left to right with 1 finger, 2 fingers, 3 fingers. On macOS, like 5 fingers sometimes actually have different effects. So we're getting more expressive capabilities now in the actual UIs of these devices. So actually a friend of mine today told me that he thinks he read that iOS can handle up to 11 distinct finger presses at a time on the screen, which is kind of interesting, that they went for 10 and then rounded up 1, just in case you have an extra. So in terms of recognizing these things, let me go ahead and open up demo did an advancer called Gestures. Source code's online if you want to play or look at the PDF thereof. And let's try to wrap our minds around what's going on in here based on a simple demonstration. So I took the liberty of going on Tommy's Facebook page, found this photo here. And then if I simulate a finger swipe from left to right or right to left simply by using my mouse and clicking, notice that I can move over to his second least flattering photo and then this one from dinner some night. And then it wraps around. So I somehow have 3 JPEGs that I stole from Facebook and then added to this app. Now, it's not quite as sexy as it could be with a nice sliding transition, but this is apparently responding now to my finger touches without using something very limited like a UI button. These are actually UI image view objects. So how do we go about, one, putting something like an image there, but more interestingly, responding to gestures? Well, let's take a quick tour of the code. So here are my 3 JPEGs. And I actually didn't crop them. I just simply trusted that the phone would only show a certain slice of them. And you can see how I'll point out where you can configure images to crop accordingly. And I just dragged and dropped those into the project. Let's look at main.m. Nothing interesting here. This is all the usual. So let's now dive into what file next if we continue our typical story. So I like to look at the app delegate just to see if anything's going on there. And I'll start with the H files because they're generally simpler. This is just boilerplate code. I have a view controller and a window pointer, as always. Let's look at the M file. This is actually all boilerplate too. I just added some comments. Nothing new there. And again, init with nib name is the init method getting called for the view controller. Let's look at my H file. Really nothing in here except for UI alert view delegate. Indeed, there's a little Easter egg. If I click and hold on Tommy, then he will yell at you. So not just pinching and swiping, you can also list for long touches, as they're called. So now let's look in the M file. So I've got a few properties, and here I started practicing this newer paradigm of the semi-private properties. Private in practice, but functionally they can still be called by anyone. So this is a little class extension. What properties do I have? I've apparently got a Boolean for alert in progress. This is just a mechanism where I learned the hard way. If I hold down my finger on Tommy's face, I then get like 10 alerts all queued up in a row because it starts hearing again and again and again and again. The event keeps firing. So I fixed that eventually with a Boolean that essentially locks multiple ones from triggering. I've got an IB outlet to something called the UI image view, which is going to be a rectangle that stores whatever image I tell it to display. I've got an index, an int called index, and this is because eventually I'm going to have an NS array of Tommies. It's going to be a size 3, and I need an index variable just to remember, is this Tommy 0, 1, or 2, or 0, or 1, or 2? So I came up with these local variables. So to your question earlier about IVARs, almost all of these could be instance variables, but properties give me automatic getters and setters. It gives me the dot notation. This is why they're so popular in iOS programming. So private methods, and again, take private with finger quotes. So alert view did dismiss with button index. We looked at this last week when you want to respond to the actual touching of a dismissal of an alert view. And just take a guess, why do I care when the user touches that button, probably, based only on the information thus communicated? The Boolean. I want to toggle the Boolean state. Once I dismiss it, I want to allow future alert views to toggle forward. So that's going to be a trivial implementation down below. Here's 2 methods that are more interesting now. Handle long press and handle swipe. They take these things that are generically called gesture recognizers. This is something that iOS gives me. It will do the mathematics of figuring out, was this a touch? Was this a swipe? What direction was it? How long did the user touch? How many fingers was it? All of this is given to you by the runtime, which is nice. And notice the common paradigm here. I'm taking an explicit pointer. I could do ID, but I know what to expect. It's going to be a UI long press gesture recognizer in this case, so I didn't genericize it, but I still called it sender, just to be consistent with these action type paradigms, even though these are not IB actions per se this time, because there's really not an interesting GUI. All right, so let's look at the GUI actually before we continue this. That's it. So originally there was nothing here. I then dragged and dropped this thing called a UI image view so that it would perfectly fill the generic view I have. So if I expand this, notice that I have an image view. And if I open the little widgets over here, and never remember where it is in order, so I'll type image, there it is, image view. So what is this? This is just a container. Think of this like an image tag inside of which can have an image, like a source attribute. That's actually the name of a file. So that's the extent of my UI. So back to the M file, where the rest of the story remains. This is boring. I'm just synthesizing my properties. No magic there. This is, as promised, simply toggling the Boolean result. So this is the message that gets passed when the user dismisses the alert view after holding Tommy's face too long. And now here's handle long press. How do I detect that Tommy's face was touched for, I think the cutoff by default is like 2 seconds, 3 seconds. It's something you can configure. If not self-alert in progress, so if the Boolean is not true, then I want to go ahead and create this alert saying, hey, stop that with a fine dismissal button. Then I want to show it. And that's it. Handling a long key press anywhere on the UI is as simple as that. Now, what I haven't revealed yet is how we know to listen for the long touch, the long press here. But this is the response to the long press. Yeah?
So when do you unset that Boolean?
When do I unset that? Up here. So when this message is passed in response to the user actually dismissing the alert view.
Okay.
So remember this from last week. This is a method that's defined in the UI alert view delegate class. And because in my H file I promised to implement this delegate, that's the agreement I have with that object. So let's ignore the swiping and focus only on the key press. Here's what happens when you hold it down too long. So where is that configured? Well, here's my initialization method, init with nib name. So again, I've borrowed this paradigm of if, self, super, and so forth. I'm initializing the Boolean to false because there is no alert, obviously, up by default. And then I need to do a couple of things of initialization. I need to prepare the Tommies. So self.Tommies, which recalls an NSArray property. Give me an NSArray alloc init with objects, because I know how many files there are in advance. I just hard-coded it. It's a simple example. Tommy1, Tommy2, Tommy3, comma, nil. Don't leave off the trailing nil. It is necessary for statically allocated NS arrays. Self.index gets 0. That's why the 0th Tommy gets displayed by default. And that's it for my initialization. So later on, though, I need to do a little bit more. Notice here's our friend viewDidLoad. Because this UI hinges on there being a user interface, that is, there being views on the screen, I can't make the mistake I accidentally made earlier of trying to do view-related initializations before the view has loaded. So I have to instead relegate that to viewDidLoad when the view actually displays or is about to display. So I first called the superclass's own method, called the same thing. Now I'm loading an image. So self.imageView.image. This is equivalent to an image tag .src in HTML. So that's how I can update the image there. Then I have UI image, which is a class. Image named is a convenience method that takes as its argument the following. Give me an image name, this self.Tommies, which is an array. Object at index self:"index, self.index. So this is kind of verbose, but this thing here is what? That's the array. This message is going to give me the object at index 0, 1, or 2. And those objects are what? They're strings, right? It was quote-unquote tommy1.jpg, quote-unquote tommy2.jpg, and so forth. That's perfect because the image name expects an NS string. So UI image named is a convenience method that takes the name of an image and essentially creates an object representing that image, a DOM node, if you will, representing that image tag. Now here's how I listen for the long press. A little verbose, but that's the norm here. UI long press gesture recognizer, and then a pointer there too. The return value of calling UI long press gesture recognizer alloc, and then I have to initialize it. The initializer here is called init with target action. So init with target, self. That means who should be alerted when long presses happen? Myself, let me know. And then action means what method should be called, or equivalently, what message should be passed. How do you pass the equivalent of function pointers? Well, I think we saw this last week. There's the special keyword @selector, which takes in parentheses the name of the message that you want to pass. And notice the colon, it is necessary. For messages that expect arguments, the colon is necessary. Otherwise, it won't be a recognized symbol. And why @selector? A helpful heuristic might be, well, it's just going to be confusing if you have action, colon, handle, long press, colon, and so forth. So the parentheses and @selector just make clear that you're passing in the name of this thing and not some weirdly named parameter. And then that's it. We add the gesture recognizer to the image view. So image views have a method called addGestureRecognizer. Actually, the parent class, UI view, has a method called addGestureRecognizer. So that's all it takes to actually tell this UI object to listen for this UI interaction. Now there is one bug if you're trying to recreate this at home from scratch, or at least mistake even I make and only recently remembered. If it just doesn't work, and you're pretty sure the code is correct because you even copied and pasted it here, notice that if I click on the image view, if I click on the image view under interaction, and you can do this in code too, this checkbox is key, and it literally does what it says. Otherwise, images are, it's unchecked by default, I think, in image view because it's not normal to touch an image, but you need to enable it if you want gestures to actually work for this type of UI view subclass. Yeah?
Then we can assume something like pinching and squeezing to zoom in doesn't work without multiple touch. Oh, yes. Yes, exactly. Multiple touch is the other option there. But in this case, I just care about the long touch. And the swiping is only one finger for this particular application. All right, so let's add that feature. So if I go back into the view controller, let's just see how to listen. Frankly, it's mostly copy-paste. It's just the name of the recognizer is a little different. I instead this time have a swipe gesture recognizer. And I care about the direction here. So notice that I'm in it with target. Let me make the window a little bigger because it's wrapping in an unnecessarily confusing way. In it with the name, view did. Here we go. So listen for right swipe. So I'm initializing this recognizer with myself, with handle swipe, which is a method I wrote that we'll look at in a second. But the swipe gesture I'm going to care about for this one is UI swipe gesture recognizer direction right, which is just an enum. It's a big constant, a number. And then I'm adding that gesture recognizer again. And then down here, this is almost copy-paste, except I'm creating a new recognizer, but listening for the left this time. But I'm now adding that same gesture recognizer. Yeah?
You're passing self as a target to all of these recognizers.
Mm-hmm.
So you can pass any class to it? Or
Any pointer, yes, a pointer to any object who's supposed to respond to those messages. It doesn't have to be self. In this case, makes sense that it's self because, again, simple application, one view controller. That view controller is really the guy running the show here. So the one for whom it's most appropriate to respond to these gestures is probably the view controller in charge. But in theory, could be anything.
Because in Android, we kind of implement an interface and then we implement callback methods.
Correct. No, much simpler here in that I simply have to implement the methods, or rather, I just have to tell the object what object to call into and what message to pass into that object. And so here's our handle swipe. This one's a little more interesting because I wanted to multiplex and handle left and right, but all in the same method. So the comments pretty much explain what this thing is going to do. Notice that I take in a UI swipe gesture recognizer pointer, which is going to be helpful because it's going to tell me was it a left swipe or right swipe. So here's how I handle it. First, I figure out the direction, and I first have to simply ask it by after casting it. Actually, this was not necessary. I did not need this cast because I already declared it in the argument. Apologies. But direction is a message that's going to give me left or right. It's going to give me back that enummed constant. So now I can have a switch. I can ignore up and down. And I don't even need this code. I just put it there to just demonstrate that you can listen for up-down swipes. Here's left. Here's right. And again, this is just simple. Not simple. This is some logic that took some thinking to get it. But all this is doing is it's incrementing the index and then using the modulo operator to make sure I go from 2 back to 0. So I have a kind of loop of Tommies going around. And this one, the math is a little more complex because I need to loop around in a different direction and make sure I don't accidentally go negative. But you could implement this in different ways. I just did these one-liners. All right, so that's gestures. Let's do one other one with some interesting use of Tommy. And that one here is transformations. So in transformations, we now have this approach for Tommy, whereby I can hold down two fingers and actually scale this thing. Not the sexiest of applications, no slight on Tommy, but it does at least demonstrate how you can pinch and actually implement the notion of zooming. How am I doing this? In the simulator, if you hold Option, then your two finger things appear, and then I can click
and essentially simulate the pinching, or you could do it literally on a phone. So how is this one working? Just to give a sense of another option here. So app delegate's the same as usual, main.m is the same as usual. Let's do a deep dive into view controller, whose header file is uninteresting, so all of the magic must apparently be in the m file again. So this one, I'll wave my hands at some of the details because it's really just some linear algebra to do fairly simple shifts around. Actually, I can move Tommy around. If I single click, I can move his whole image around, known generically as a, oops, I dismissed Tommy, just to prove that we're trying to do multiple things here. I can move him around like this, and that's a translation, moving him along a vector that has an x component and a y component. So here's the m file. Here is one of the uses of local instance variables that I alluded to needing sometimes. In this case, it's because I need a C struct in there. So I'll come back to that briefly. I have some properties. One is an IB outlet for my image view. Another is a value that represents the scale. So as I pinch in and out and I want to scale Tommy, by default he's 1.0. But if I have him, he's 0.5 or 2.0 if he's doubled and so forth. And then here's my array of Tommies before, which actually I don't need because I decided to simplify and just have one. So here I have a couple of private methods, so to speak. Again, private should be in quotes. Because it's not quite private. And then I have some initialization. First, I'm initializing my remembrance of Tommy's scale to 1.0. Translation x.y, I'm initializing to 0, 0. So the translation, think of as an offset. So by default, Tommy is properly aligned in the upper left-hand corner. 0, 0 means he's not shifted in any way. If it were 10, 0, that would mean he's shifted over 10 points. And if it's 10, 10, then he's also shifted down 10 points. So I just need to remember that. Now here is where there's some corner cases with the use of properties. In Objective-C, is this a property? So it's actually not. So if you scroll up, underscore translation is actually a C struct. So CG point, if I hold Option and click on the keyword, I can see looks like this. It is a struct called CG point that has two components, a CG float, which is just a float, and a float y, two different fields. So the problem is that C uses dot notation to access struct members. Unfortunately, that can lead to confusion between properties and structs, and indeed, generally not a good thing to make a struct a property. The reason being, not really the confusion that ensues from dot notation, but because what happens when the getter and setter is implemented, because they are implemented in a it's a struct. You're going to use assign because it's not appropriate to use weak or strong or copy because they are meant for pointers. So assign will literally make a copy of the struct. So long story short, if you try to declare a property whose instance variable is actually a struct, when you use the getter or when you use the setter, you're really getting copies of that struct because a struct is just a primitive. Right? Or it's equivalent functionally to a primitive in that when you call the getter, you're going to get a copy of the whole structure. So you can make changes to x and y that are returned by the getter, but you're wasting your time because those changes won't propagate. So in short, and this happens, and we'll see again when we talk in a week or so about core graphics, two-dimensional graphics in iOS, generally beware using properties with C-style structs. Not just because of the syntactic confusion of dot notation, but because of an issue that I'll point out in more detail when it arises again. So let me wave my hands at some of the mathematics, but just assure here that handle pan and handle pinch simply do a little bit of arithmetic, something called an affine transformation down here to handle the movement of this image along the x and y axes and also the scaling of this UI image view. But really, for our purposes right now, I would say the more interesting part isn't so much the mathematics, and really the matrix multiplication that's happening above, but the fact that we're telling the gesture recognizers to send handle pinch to me or handle pan to me. And let me propose as an at-home exercise to read through that and then hold Option and click on any of the structs or methods of interest just to see how they're actually working. Any questions on the second of two Tommy apps here? All right, so let's take a look at for time's sake, let me go ahead and we'll defer some matter. Let's do a quick discussion of storage, but not focus on code till next time here, so that we can have a conversation about Evil Hangman in Project 2, so as to give everyone a bit of a mental model for going into that. We'll discuss in more detail next week. There's a whole bunch of forms of storage, and the one you really need to use for the staff's choice of iOS is actually relatively straightforward. So don't worry that this will put us at a disadvantage in terms of time. There's this thing called property lists, and the spec discusses what this is, but a property list is just an XML file. But it's an XML file that's structured with XML elements to represent an array or a dictionary. Generally, an associative array is a dictionary. So property lists, we give you a property list called words.plist, which has like 140,000 English words in the form of an array. And by array, I mean there's literally an XML element inside called open bracket array, close bracket. And then inside of that is open bracket string, close bracket, and then 140,000 such string XML elements. Soplists are just common in iOS and in macOS programming, because it's just a nice, simple way of storing data, especially if you want to include a bunch of prefab data with an application. NSDefaults, meanwhile, is a class that comes with iOS that, as you'll see and will be recommended in the spec, will allow you to very easily keep track of defaults in a program. So simple little settings like what's the word length that I want Evil Hangman to play? How many guesses should the user get? Those two things in particular. So NSDefaults generally is ultimately backed by just something like a property list, but you don't need to care, because as you'll see in the documentation for NSDefaults, you can essentially just set values and get values and let iOS figure out how to store those things for you. SQLite. So iOS does support SQLite, which means it supports SQL, just much like Android, which is just going to be the illusion of a SQL database, but it's actually just stored in one big binary file on the local file system. But you now have the expressive capabilities of selects and inserts and deletes and the like. Unfortunately, the API or the library for SQLite is C-based, so as we'll see next time, which you won't need for the Evil Hangman project, it's not the cleanest interface. You kind of have to jump through some hoops and do some old school sort of C-style pointer programming in order to achieve relatively simple things that would be much easier in higher level languages today. Thankfully, in iOS 5, we finally have good XML and JSON support without the need for third-party libraries, so that you can, as I think we discussed briefly last week, actually make connections to web services and the like and ingest data much more easily than you could a few months back. And core data is an abstraction layer on top of any one of different storage mechanisms that allow you to not even have to care about what SQL is or even know what it is, but model a little more graphically, if you will, your entities and your relationships, and let iOS figure out how to implement that underneath the hood with SQL tables. So in short, a whole bunch of ways to store data persistently. The ones that will be germane to Evil Hangman will be property lists, because we give you one. We actually give you two on the website. One's smaller for testing, and NSDefaults. And really, NSDefaults, with some Googling and some looking at the Apple documentation, very easy to set values and get values back. So, Evil Hangman itself. So recall that Evil Hangman is going to be an opportunity to implement a more mischievous version of the traditional hangman game, whereby computer chooses a word and human starts guessing letters, and you have a finite number of guesses before you lose the game. But in Evil Hangman, if anyone recalls, what actually happens? Yeah, so the computer cheats. By not actually committing to a word in advance, it commits to a word of a specific length, like 6 or 7 or whatever. But every time you guess a letter, like the letter A, the computer looks through its database of 140,000 words, throws away all of the words that have A's in them, and then says to you very confidently, nope, no A's, because it still has some words to choose from. Then you choose E. It does the same thing. It throws away all of the E words in addition to the A words, and now it can say, assuming some words are left, and there will remain words after just 2 guesses, nope, no E's in this word. And again, and again. Now eventually the human might, by luck often, paint the computer into a corner where the user says P, and just by chance, all of the words that remain happen to have a P in some location. At that point, the computer needs to make a decision. Some of those words have P here. Some of them have it here or here, beginning of the word, middle of the word, end of the word. Now the computer's got to pick one of those positions. Now, which one is not obvious. The spec actually allows you to make certain assumptions that you can bucketize all of the words. Put all of the words that start with P in this mental bucket, all the words that have P in the second placeholder here, and then all the words ... that have P at the end of the word over here, and then figure out which of those is the biggest buckets, and then use those remaining words. And you want the biggest bucket so that hopefully that just makes the game harder for the user. Now, how to do that is a little less obvious. Thankfully, Objective-C gives you a lot of functionality, a lot of collections. Dictionaries will probably be your friends. Arrays might be your friends. But there's actually some interesting computer science there with actually treating these things as what would be generally called equivalence classes. Sets of things that are functionally equivalent, but you have to somehow identify which class, which equivalence class, which bucket each of these words belongs in. Now, eventually, hopefully, you have run out of guesses and the computer wins, and then it reveals that the word was bear or something. Duck, I think last week was our answer. Remarkably simple, and yet the user thinks, oh my God, I should have gotten that. But no, I mean, the computer was very deliberately evading your guesses. So it's actually quite fun to call Hangman. Don't call your program Evil Hangman, because then invite your significant other or friends or kids over, have them play the game, and really have their minds a little bent. Now, with that said, when messing with other people, from personal experience, come up with your own shorter P list of words, even if it just has a dozen or half a dozen words. Because if you use a corpus of 140,000 words, frankly, just statistically, they're not going to know what the word is. At least if they have my intellect. We've played this game before with the huge corpus of words, and I didn't know what the first 3 words that actually were played were. So it's not as much fun if you have no idea what the words are. So pick simple words, like duck and bear, like I did last week to you when I learned this the hard way, when the first demo didn't go over so well. All right, so with Evil Hangman, you are advised to start with a utility application. So I'm going to go ahead and do that. And let me just give you a quick verbal tour through the template so that for today and tomorrow and Wednesday afternoon, you have an opportunity to dive in with a bit of guidance. And then on Wednesday of this week on campus, per the Google Calendar on the website, Tommy's going to lead a more detailed walkthrough, literally walk through all of the bullet points in the spec as to what direction you might head in, design decisions you can make. So consider this really just an overview. And if you can't come to campus, totally fine. It will be filmed and placed online by Thursday on video. All right, so let me call this Hangman. I'm going to leave some defaults. I'm going to go ahead and turn on automatic reference counting. I'll leave the others unchecked. I'm going to go ahead and click Next, save it on my desktop, and let's see what I get out of the box for free again. So I've compiled this. Simulator is running, and a utility application looks like this. You have a big gray box, but if I click this, I get the very sexy transition, which frankly is better already than most of the demos I've written, that does this little spinning effect. So what we're about to see is that this thing here is what the template calls a main view controller, and the opposite side is a flip side view controller. So let's take a quick tour of this so that at least if you're really raring to go, you have a sense of where to dive in. So as always, let's look at main.m just to confirm that it looks no different from usual. Now let's look at appdelegate.h. It too is pretty vanilla, except notice that the app delegate implements, actually, notice the one difference here is that it's now main view controller. It's not view controller, but that's just really an aesthetic detail. App delegate, this is actually the same. And like you can throw away most of these method stubs. So main view controller, I would propose that 6 files remain. Main view controller all the way down to these nibs. So let's look at the first nib, main view controller.nib. What is this thing? Well, let's expand the hierarchy. It's just a button. It's a UI button. It looks different from before because it's not one of those rounded rect buttons. But if I pull up the attribute inspector, I can make it look like that. So now it's just a round looking button. I can make it a much bigger button. So even though it looked like a nice little informational icon, it's still functionally the same. So I get that for free. And now if I look at the flip side nib, I have this. What is this hierarchy? Well, we haven't used these yet, but notice it's a little more hierarchical this time. I have a view with a navigation bar, with a navigation item, with a button, a bar button item. Now, what does this really mean? It means that whoever made this template scrolled down through this list, looked for the thing called navigation bar, and dragged one of these over. And then he or she found a navigation item and dragged this over here. Oh, not that one. Bar button item. Drag this over here, but obviously did it at the top of the screen. So in short, these templates were just things that people made to be illustrative of popular iOS paradigms. So that's where we're at now. If I right-click on this, notice that I have apparently an IB action wired to it. And this makes sense. When I click the Done button, a method called Done is apparently going to get passed to file's owner. And who's the file's owner of the flip side view nib? Close, flipsideview.m. So that class, as we'll soon confirm. And now let me go over here and see on right-clicking Files Owner, I have with these, this default property called View that I always get for free because of class hierarchy, and I have a reminder that I'm going to receive this action. So there's no outlets, and that's fine because there's nothing to talk to. In fact, I can change this and just call this Settings, for instance. I'm already halfway to implementing Evil Hangman because I can go over here. And then if I really want, this isn't strictly required, I can do Navigation Bar up here. I can do Hangman. I can do, I need a settings thing. So that could be settings. When you read the spec, you'll see that you need a new button. So I can say something like new here. I kind of want it to stand out. So I can make it a done style button, which now makes it a little bluer. If I really want, I can have this be called settings. Whoops. Settings. I can technically ditch this thing, and I can actually wire this to done, or show info, as the method is called. On this side. So relatively easy to start mocking up a fairly common UI, at least if you don't want to stray from the conventions. All right, so let's now dive into main view controller and see what's interesting here. So first thing that's interesting about this file is that it's pretty minimalist, but it's obviously declaring a method, show info, but what's it also citing, which we haven't seen before? Yeah, so flipside view controller delegate. This is not some fancy protocol that comes with iOS. This is what someone at Apple decided would be fun to create and introduced it into the template as an example of how to do protocol type programming. Well, what do I mean by this? Well, notice that this file is importing the H file. So I'm in main view controller.h, but notice I'm importing the flipside view controller. So let's now look there. Flipside view controller.h, interesting. So again, this is not in the default SDK. Some developer at Apple just decided, you know what, I want to standardize the means by which main and flipside controllers talk to one another. And the way to standardize how two objects talk to one another is by way of this protocol. Much like silly human protocols like shaking hands. That's how two humans introduce themselves to each other. Same deal here, how two objects will talk. This protocol says that anyone who implements this protocol should implement a method called flipsideViewControllerDidFinish, and it will pass to me a pointer to the flipside view controller. So what's going to happen is this. By default, I run the application and I see the main view controller. I click the little I button, or the settings button that I changed it to. Things start to flip around. As soon as the user clicks done, the flipside view controller passes that message to the main view controller object. Why? It's up to the main view controller object, as we'll soon see, to actually dismiss me. So a view controller can't dismiss itself. Main view controller is going to do this. And if you think of it, even though it's flipping this way, think of it sort of HTML style. It's a modal window. So when you click the I icon, think of a modal window as coming up like this. As soon as this guy, the flip side view, is done doing whatever it wants to do with the user, and the user clicks done, you want him to go down. But he can't pull himself down. The parent window, the main view controller, has to do that. So how do I tell the main view controller, done, you can dismiss me? I being the flip side view controller, will send that message. And then the main view controller can listen for it and then dismiss me. Or aesthetically, it's this. But modally, it's this idea. All right. So what else is in here? Notice I have this, which is an interesting use of some of the ideas we've explored thus far. I am flipside view controller. I apparently have a property of type ID, but of type ID whereby whatever that object is, it has to implement flipside view controller delegate protocol, and I'm going to call it my delegate. So in other words, your main view controller, flipside view controller's in front. We already decided that the flipside view is going to send me a message. How does the flipside view controller know to whom to send that message? Via that property. So the flipside view controller we're about to see will be handed a pointer to the main view controller by the main view controller as a sort of reminder, let me know when you're done executing. And that's why this flipside needs to keep that pointer around. Yeah?
So the flip side is the child of the main view.
Correct.
Does that mean that while the flip side's up, the main view can't be taken away by memory management?
Good question. When the flipside view is in view and the main view controller is still in memory, its view can be evicted because it is not visible on the screen. So
it's the parent of that, just because it's not visible.
correct. Correct. All right, so good corner case. Once you kind of have a basic UI working, try that experiment and try it up until submission time, whereby if you pull up the flip side view, try simulating a low memory warning and then dismiss the flip side view and make sure that your original UI still works and you didn't lose data or it's not mangled because you didn't reconstruct your view. So real quickly then, in flipsideviewcontroller.m, there's actually nothing interesting going on here except for this. So this is the done message that the main view controller that the flip side view controller expects when I click the done button. So when I click the done button, this method is called. Notice that the flip side view sends a message to his delegate. That is, the main view controller sends him this crazy long named method, passing in a pointer to himself, so I know who was dismissed. And then lastly, if we then look at the implementation of flip side view controller did finish in the main view controller by scrolling down here, it's super simple. When I said that the main view controller's job in life is to dismiss the modal window, how do you do that? With a simple call there. Self dismiss modal view controller animated, so it sexily disappears. And how did this all start? Well, even though we've told the story in reverse order, here's the show info method. This is the method that's called when I click the little eye icon to start flipping things around. I first instantiate a flip side view controller. I initialize it with the nib. I then remind that flip side view controller that I am your delegate. Let me pass any messages to me, hence the assignment of self. And then I do the sexy little iOS thing. I make the transition style UI modal transition style flip horizontal. That's the stupidly named constant that flips it around. And now, though kind of necessary if you don't have namespaces. And then here is how one view controller presents another one modally. Self, present modal view controller, passing in a pointer there too, saying a Boolean of yes, make this a sexy animation. And don't make it just appear. So this is a lot. And you'll find in the spec, if you haven't read through it already, that we try to fairly pedantically walk you through the source code so at least you can follow your way through the template code and then be on your way. But again, this Wednesday, Tommy will walk through not just the code, but rather the specification, what features are expected and what technical design decisions you might make. So I would encourage you, read the spec, maybe even start playing if you're super eager to start. But if you're a little uncomfortable and really are a little overwhelmed by the first iOS project, rest assured there'll be a nice support structure executed on Wednesday nights. Why don't we adjourn here, and I'll stick around for one-on-one questions. Otherwise, Gloria is up next with section.